What is up, YouTube, and welcome to another video. I'm super excited about this one. We're going to be taking a look at HashiCorp Key Vault, and I've used Docker and Kubernetes for many years now, but I've not used a Key Vault implementation. So I have a lot of unanswered questions. I had to go through all the documentation, and in this video I'm going to show you everything that I've learned about HashiCorp Vault. So in this video we're going to take a look at the Getting Started guide. We're going to take a look at how to get Vault up and running. We're going to take a look at all the components that makes up a Key Vault. We're going to take a look at the configuration of Key Vault and all the things we have to know, the concepts around Key Vault. So without further ado, let's go. So why do you need a Key Vault? I've always been skeptical about a Key Vault implementation. Let's say I have an application and I have a database, and I have a database with a password. Now, usually I would just put that password in a Kubernetes secret, but if I ask an engineer, what do we do with a secret? The answer is always put it in a Key Vault. And I've always been skeptical and asked why a Key Vault, because technically we're just trading one key for another one. Now, instead of having to secure the database password, I have to secure the Key Vault key. And if someone compromises that key, they have access to all database credentials, not just the one I was trying to protect. So Vault actually has a lot of features that help with this. So in this secret management series, we're going to demystify some of these issues. So for those of you who are new, this is the Docker Development YouTube series. Everything I cover in this video is all documented in GitHub. You can actually go to the source code. The link is down below. And you can follow along to everything I'm doing in this video so you can learn with me. So one cool thing that got me really hooked on Key Vault is this. How many of you have production credentials for a database or something on your laptop? Because let's say you provisioned it in the cloud and you have the key, because you use the key to access it, and you might have shared the key around for other operators to, or developers to do some troubleshooting. Maybe someone had to do access the database while you were on leave, so that you sent them the key. So this is a normal thing, and it happens. And production credentials tend to go between users very easily. So in this video, we're going to be looking at, on the root folder, the HashiCorp folder. I have a Vault folder in there and the server implementation. So I have all the files in here that's required to get a Vault server up and running. So the HashiCorp documentation is really cool. If you head over to learn.hashicorp.com/vault, they have a Getting Started guide, and this is the documentation that I followed from scratch. Followed all these documentation. I came down to here to deploying the Vault, and in this video I'm going to show you everything I've learned. But if you get stuck with any questions and stuff, this is a great resource to come and just look at everything Vault related. Now, when looking at some of the features and other videos and tutorials that made up the Key Vault, one of the big takeaways and some of the things that I had to demystify for myself was, how does the Vault solve certain real life problems? Now, I mentioned I have a database and I have a Kubernetes cluster, and on that cluster I have a pod. This could be a microservice that requires access to the database. So now in traditional world, we used to go and spin up the database, and we have a password, and then we create a Kubernetes secret in the cluster, right? So there was a human involved that has to get the secret from point A to point B. And that is where there's a lot of security concerns with credentials being leaked when it moves across the systems. Now, in the Vault implementation, we use a Kubernetes service account. So a Kubernetes service account is a way of us trusting the pod and giving the pod some kind of identity. So we know that this pod runs as the service account that we trust. Then we have a Vault. So I'm going to show you, as part of this demo, we're going to spin up a Key Vault, but the whole concept is something I want to try and achieve. Not only get the Vault up and running, but in a future video, what I want to do is see how we can move secrets automatically between our database and our pod. So Vault has this thing called dynamic secret injection and secret creation. So what happens is our pod authenticates to the Vault using that service account. And then what happens is the Vault will verify with the Kubernetes API that this is the pod that's trying to access the secret, and yes, I trust it or not. And then what will happen is the Vault will go and generate and fetch a temporary credential. So it actually goes to your database, and I've seen this working with MySQL, and I'm quite keen to see how we can do this on other cloud providers and other systems to go and create that database credential. So it creates a temporary user for us, and we might put the pod name as the user, so we know that that pod accessed the database. And then what it does is it fetches that and creates a secret and mounts it into the pod automatically. And then one of the cool things I've seen is that the pod now can use that secret for the life cycle of the pod. So if the pod gets deleted, what happens is, let's say the pod is now gone, Vault will automatically go back to the database and clean up that temporary credential that it created. So that database user doesn't have to be maintained by any operational team. So whilst going through the documentation, one thing that I've stumbled upon that the HashiCorp team recommends is the Vault Helm repo. So this is the Helm chart to install Vault. So this is the Vault Helm chart. We want to go into the templates directory, and we'll see that there's the injector components and there's the server components. Now, my theory is always, if I want to learn something, I'm not just going to install the Helm chart because it's going to do all the work for me. So what I have done as part of this is I've taken the server YAML out of the Helm chart, and I've converted all the server components into basic Kubernetes YAML. So I've removed all the Helm syntax. So if you open up these components, these are the basic bare bone Kubernetes manifests for the Vault server component. She's in love with who I am. So the Vault has 3 different modes that you can start it up at. It's got the dev server mode, it has standalone mode, and HA mode. Now, if you're already familiar with Vault and you know all the ins and outs and you just want a dev server up and running that you want to develop against, then dev server mode is great. If you're new and you want to start out, I would highly recommend standalone mode, but then also be aware of all the Vault concepts, and we'll take a look at the unseal and seal and all the different storage mechanisms, because HA mode is really important for production use, and you'll understand why. Now, Key Vault also has another mode called standalone mode. That's basically where you have a single instance of Key Vault. Now, it's very, very important to know when a Key Vault starts up, it doesn't have access to its secrets. A Key Vault itself can never access the secrets on that it's encrypted. That's because those secrets are encrypted, and Key Vault by default does not have the encryption key. And that's where there's a concept of seal and unseal. So when a Key Vault starts up, basically it's already been, the vault is sealed. The Key Vault does not have access to it. It does not have the encryption key. One of the downsides, if you're running with a single instance, firstly, you have to manually unseal that Key Vault for it to become operational. And we'll take a look at sealing and unsealing in a minute. Now, if you're running that single instance on Kubernetes and for some reason the scheduler decides to restart that pod, or the node dies and the pod moves to another instance, your services will be down because that instance will come back up, but the vault will be automatically sealed again, so you'll have downtime. Now, I've mentioned the HA or high availability mode. Now, this is really important for production use. As I've explained earlier about the seal and unseal, when a vault starts up, it's automatically sealed, and when a vault process restarts, it becomes sealed again. So there's this whole thing about operational folks having to unseal the vault manually, providing it the right keys to unseal it so that the encryption key can be generated. And this is part of the security feature of Vault. When it runs, it does not have the encryption key stored anywhere on disk or in Kubernetes. Now, it's important to know between developer mode, HA mode, and standalone mode, it's important to strategize about the storage that you want to use. The storage with Vault is very important. Depending on the cloud provider you're using, you want to make sure you use the right persistent volume. Okay, so when it comes to Vault, I believe the storage is the most important part. So 2 things I've created that wasn't part of the Helm chart was my storage components. So if you're in a cloud provider, it's very essential that you pick the right storage that's available in that cloud provider. So some kind of a managed disk or whatever storage component it is. If you're running Docker locally, I've used a feature that is available from Kubernetes 1.14 and up called the persistent volume for the local persistent volume. So if we go into server.-pv, we can see I have a persistent volume, and its type is local, storage class manual. It's just a 1 gig local storage. And basically what this does, when I deploy this will create a storage on my local machine for /mnt/data. So I'm going to mount this folder into my Vault container. And now I also have a PVC, which is a vault claim. So I want to claim the entire space. Now it's also important to note that there is another technology called console. That's one of the other recommended approaches of high available storage for the key vault. But in this demo, just to keep things simple, I'm just going to mount it to a local volume on my node. Now when the vault initializes, it's going to give you 5 keys. These keys are meant to be distributed and not stored together. Now whether you use a system to automate that, or you just go by a traditional approach where you take the 5 keys and you give them to 5 different people, that's up to you. The vault, when it starts up, is sealed. That means it does not have the encryption key. Now the way sealing and unsealing works is that it needs at least 3 of the 5 keys in order to unseal. So what happens is you might have person A provide key A to the vault, and the vault will wait and only become unsealed when all 3 keys are provided. So person B will come provide their key, person C will come provide their key, and the vault will change its state from sealed to unsealed. And what happens is the vault will craft the encryption key and keep it in memory and use that to decrypt and encrypt secrets coming in and out of the vault. When a vault process dies, it loses that in-memory encryption key, so it would need to be unsealed again. That's where the concept of auto sealing comes into place. Now we're not going to cover auto seal in this video. Auto seal is basically when you have another vault or another process or another system that allows you to automatically unseal that vault. So one of the important things is to run your vault in HA mode. So if you have 5 instances in your Kubernetes cluster, you want to run at least a vault on each one of those machines. That means when one vault process dies, that doesn't matter, because you can go in, an operator can get an alert and they can come in and unseal that vault as long as you have at least one instance of vault up and running. So this demystifies the whole theory about now I have encryption keys that I have to protect. It's basically you distribute your 5 keys, and when you want to unseal, you bring the 5 keys together, and basically the encryption key is not stored anywhere within your Kubernetes cluster. Now, before we look at the deployment and the stateful set, one thing to know, if you're going to mount a volume or work with a cloud provider storage, you want to make sure that your key vault gets the right file permissions. So I'm mounting a folder from my host, which has basically root privileges, that folder. It's owned by root. So I have to do a little init container. So if you look at the stateful set, there's a volume that I created here called data. And this is my persistent volume claim that I'm going to be mounting inside of the vault, right? To persist my keys. And then I created this init container, which is a setup permissions, which is going to run temporarily as root. But what it's going to do is it's going to pass ownership to vault data folder. So it passes ownership to that. And then that container stops running. So this will give my key vault or my vault pod the right access on the vault data folder, because the key vault will run as a non-privileged non-root user. It's just called vault. Now before we deploy, let's take a look at everything that's involved here. So for the deployment, I have cluster role binding. So I've kept all the permissions here. There's a service account over here that we're going to be using. We also have a service to expose our vault. So we also have, as I said, the service account. And then I have the stateful set. Now the stateful set is the vault itself. That's a critical part of this demo, is to get this guy right. And then we take a look at the configuration. Now if we take a look, I'm running a single instance mode. So I have replica 1. I have some labels specified, just some basic stuff in the security to not run as a non-root user. I have my init container to pass permissions to the vault in terms of the file system. There's 2 volumes that are critical here. One is the data, which is where to store all the vault data, and then the config. And then we have the container, which is the vault itself. So we have some security permissions for that vault. We're running vault. This is the version we're running. And then these are all the basic entry points that's in the default Helm chart. We also have a couple of environment variables, and then the vault address. So this is the address we're going to be accessing the vault on. So port 8200. We have our 2 volume mounts, and we have our ports, and we also have a readiness probe and a liveliness probe. Now it's important to know that when the vault starts, it's going to be sealed by default. So you're probably going to find that this vault will go into a crash loop until we actually initialize it fully, because the vault has to be fully initialized before it can be used. So the readiness and liveliness probe will keep restarting it until it's operational. So this is really simple. To spin it up, we're going to say kubectl create ns vault example, and then what we're going to do is say kubectl apply. In the vault example namespace, we're just going to apply the entire folder. So that'll go ahead and create our vault. Now, if we run kubectl get pods, you can see our vault is up and running. Now, it's very important is to make sure you configure this guy correctly, because the whole security is tied to the configuration. So you're going to want to go ahead and enable things like TLS. You're going to want to set up the right policies. You want to set up the right storage and everything that's recommended to run it in the right mode. Now, for this video, I just want to focus on basically getting this up and running in the bare minimum that we're going to need. So this is the smallest config. So what I'm going to do in a future video is probably look at how to configure this in a highly available manner, so we can run more than one instance and maybe use a different type of storage mode as well. Now, if you leave this running for too long, you'll see that it automatically gets killed by the readiness and liveliness probe. That is because the vault has not been initialized. It's basically sealed. So the readiness probe is trying to get the state of the vault and see that it's not usable, so it kills it. So what we're going to have to do is initialize the vault. So what I'm going to do here is I'm just going to delete the vault, the pod, so that it gets recreated. So what I'm going to do is say kubectl exec it vault, and I'm going to get a shell terminal into that. I'm then going to say vault operator init, and that's going to initialize our vault. Now this will give us the 5 keys that I mentioned earlier. So what you're going to want to do is grab this information, and I'm just going to paste it here so that we have it. It gives you the root token as well as the 5 keys. This is the keys that you don't want to store together. You want to kind of hand them out either to different systems that's going to do the auto unseal, or to different people that can do the manual unseal. So to unseal the vault, we're going to do vault operator unseal, and it's going to ask you for a key. So what you do is you pass in a key, and you can see it's updated its seal progress to 1 out of 3, but it's still sealed. So now the next person should be coming in and run the same command, and then the second person will run the command and type their key, and it'll go from 2 to 2 out of 3, and then the third person will come and run the same command, and they will be able to unseal it. So now we can see our vault is no longer sealed and it's been initialized. Now if we go out of that pod and we do another get logs, we can see our server is configured, the server is started and up and running. So now our vault is unsealed, it's ready to be used. So pods can now access secrets, create secrets, and we can go and access the user interface and also manually create secrets if we wanted to. So this is the algorithm that the vault uses. It's called Shamirs secret sharing. Now this is an algorithm in cryptography that's a form of secret sharing, where the secret is divided into parts, giving each participant its own unique part. So this makes it really simple that the encryption key is not stored inside the vault. The vault basically passes out these different keys to different folks, and they can bring the key in. So that means that no one single person can unlock or unseal the vault themselves. Now this depends on the user, right? If I go and store all 5 keys together and I'm the master of these 5 keys, that is my problem. I'm basically compromising the whole security feature of the vault. So it's important to either distribute these keys among different people and have this unseal process manual, or you build 3 different systems that basically auto unseal the vault. So once you've properly unsealed your vault, and remember that the readiness probe is and the liveliness probe is gonna delete that pod. So if you attempting to unseal it and you get halfway and the pod dies, you're gonna have to start again and unseal it. So what you want to do is make sure you go in, unseal it, and what you should be seeing when you run get pods, you should be seeing that the pod is in a ready state. If you see that it's not 1 out of 1 ready, you know it hasn't been fully unsealed. So now with the pod up and running, what we're going to want to go ahead and do is we're going to want to port forward into that pod. So I'm going to say kubectl port forward on 8200. And when we run that, we can now go and check out the user interface. So once we've port forwarded, we're going to need the root token. So we grab the root token, and then we head over to localhost, to this URL, localhost on that port, and we'll have to sign into the vault using the token. There's also other mechanisms. So you can have like Active Directory and GitHub authentication, or you can just have a username and password. So, but the default one here, we go with the root token, we sign in, and now we can start creating secrets. There's some policies. So basically we can define a policy that says only my pod can access a certain secret. So this whole thing about if you compromise the vault, you don't necessarily have access to all the secrets. So you can basically divide it up and have different policies, so a certain service can access a certain secret. So some of the things we'll take a look at is the secret engines. You can go and enable a new secret engine, and you see here that it's got different cloud secrets. So Active Directory, AWS and Azure and Google. We also have things like SSH, certificates. We have console databases and a bunch of other cool stuff. So we're going to be diving into some of these and see what this thing is capable of. But I want to show you the basic one. It comes with this cubbyhole secret engine where we can just go and create secrets. So you can go ahead and create like a path of the secret. It can be a JSON file format. It's very cool. So what we'll do in a future video is we'll create a microservice in a specific programming language. We'll run it as a pod on Kubernetes, and we'll see how we can access a secret using a pod on Kubernetes. So that is it for part 1 of the secret management series, guys. I hope you guys enjoyed it. I'm trying to keep these videos short and sweet and packed with information. So in this video, we just got the vault up and running, learning the basics. In the next couple of videos, we'll be taking a look at how to configure the vault for highly available modes. We'll also take a look at some of the best practices, and also how do we create a microservice that's going to be consuming a vault secret. How do we move secrets between the vault and applications securely? So I hope you guys enjoyed that video. Let me know down in the comments what sort of issues you guys are facing with Vault, so you can help drive the direction of this series. And like and subscribe, and until next time, peace.